Good afternoon, everyone. Thank you for coming. Welcome. Here to present Neil deGrasse Tyson. Give you a little background on him. He was born and raised here in New York City, where he was educated in the public schools, clear through his graduation from the Bronx High School of Science. Tyson went on to earn his BA in physics from Harvard and his PhD in astrophysics from Columbia. In addition to dozens of professional publications, Dr. Tyson has written and continues to write for the public. He is a monthly essayist for a natural history magazine under the title Universe. And among Tyson's 9 books is his memoir, The Sky Is Not the Limit, Adventures of an Urban Astrophysicist, and Origins, 14 Billion Years of Cosmic Evolution, co-written with Donald Goldsmith. Origins is the companion book to the PBS Nova 4-part miniseries, Origins, in which Tyson serves as on-camera host. The program premiered on September 28th and 29th in 2004. And beginning in the fall of 2006, Tyson appears as the on-camera host of PBS Nova's spin-off program, Nova Science Now, which is an accessible look at the frontier of all the science that shapes the understanding of our place in the universe. Tyson is the recipient of 9 honorary doctorates and the NASA Distinguished Public Service Medal. His contributions to the public appreciation of the cosmos has been recognized by the International Astronomical Union in their official naming of asteroid 13123 Tyson. On the lighter side, Tyson was voted sexiest astrophysicist alive by People magazine in 2000. Tyson is the first occupant of the Frederick P. Rose Dictatorship of the Hayden Planetarium here in New York. He also lives here in New York with his wife and 2 children, so please help me welcome him.
I think the word is directorship, not dictatorship of the Hayden Planetarium, just in case you... Yes, I'm proud of you for getting through all of that. First, I want to hear, I've never been to Google before. This is pretty cool. Google is now a verb, as you know, to be Googled. You tell that to someone old enough, they wonder if it's some illegal thing you do. You know, I Googled her the other night. It's like, oh, call the cops, you know. Let me compliment you. You occupy a building that actually has a 13th floor identified in it. 80% of buildings in New York City that are taller than 12 leave out the 13th floor. So I feel like going with a Sharpie and crossing out the 14 and putting in 13 because that is the 13th floor. So I just want to be I'm proud of you guys for finding such a building. So I hear just talk about Pluto. I like this little chair here. This is good. This is good. Pluto. I'm told this audience has a high geek index, so I can go places I might not otherwise go with other audiences. So may I, with your permission? Yes, absolutely. Excellent. Okay. Let's go way back, farther back than you might have bargained for. There was a day when there were 7 known planets, and the word planet had an unambiguous definition, clear and simple, defined by the ancient Greeks, planetes, meaning wanderers. There were 7 objects in the sky that would move against the background sky. So Mercury, Venus, Mars, Jupiter, Saturn, the Sun, and the Moon. 7. Unambiguous. Everybody could agree that those were the planets. And it's those 7 names drawn from Roman and Norse mythologies that landed as the 7 names for the days of the week. You have Saturdays after Saturn. I don't know if you knew that. It's named after Saturn. Sundays named after the sun, yes. Monday, the moon, this sort of thing. And you combine Greek, Roman, and Norse legends, you get all 7 days of the week. All right, fine. Well, there you go. For a couple of thousand years, you get to Copernicus in 1543. He says, well, maybe the sun is in the middle of all this. And if we are, then Earth goes around the sun like these other things we had been calling a planet. So maybe Earth is a planet. And so overnight, with the publication of De Revolutionibus, 1543, Nicholas Copernicus, Polish astronomer and mathematician, overnight practically, we went from 7 planets down to 5 because we lost the sun and we lost the moon because we go around the sun, moon goes around Earth, and we gained the Earth. So we went from 7 down to 5 up to 6. And there it was. But that definition of planet wasn't formal. It was just, do you go around the sun? Okay. You're okay. Good enough for us. All right? Now, quite by accident, in the late 1600s, William Herschel, who is a famous British astronomer, had the biggest telescope in the land. He's combing the sky, just looking for stuff, finds a planet. Actually, no one had ever discovered a planet before, so he was in denial that he had discovered a planet. So you read his notes, and he says, and other people's notes about it, it says, this is he thought he discovered a comet. Fine, because he saw it move against the background. People knew about comets. You could find those. But you're not going to discover another planet. This has been, you know if there was a planet, all right? You're not going to discover a planet with your telescope. So you read his writings, and it says, a peculiar comet this is. It refuses to show a tail or a fuzzy sort of coma around so it's a misbehaving comet when in fact he had discovered a planet, all right? Then it was time to name the thing. Well, being like a good scientific researcher, you want to name it after like the people who are funding your research, right? So he named it after King George. And so for about 50 years or so, if you look at the textbooks of the day, there was the list of planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, and George, right? There it was. George. So, no one had ever named a planet before. So you knew that was wrong, but you didn't know why it was wrong. And they finally figured out, okay, planets are named after Roman gods or goddesses. So we got to back out of that one. But the British were the most powerful force in the world, economically, politically, culturally, militaristically. So you don't want to really piss them off. So if you're going to concede a Roman name for the planet, you got to give something up. So up until then, the tradition for naming planet moons has been to name the moon after an assorted Greek character in the life of the Greek counterpart to the Roman god after whom the planet's named. In other words, take Jupiter for a moment. One of Jupiter's moons is Ganymede. Ganymede was the manservant for Zeus. And Zeus is the Greek counterpart to the Roman Jupiter. Okay, got that? That's how that works. That's to give an homage to the Greek and Roman history that fills the skies. Uranus, the planet discovered by Herschel, is the only exception to this rule. The moons of Uranus are named for assorted characters, fictional characters in Shakespearean literature. The only exception. So it's kind of cool. So you look at the moon names of Uranus, it's like Puck, Oberon, Portia, a lot of characters from A Midsummer's Night Dream. Give me a few more. Just name one, and probably I got a moon for you. Titania, that's right. And there's another one with an Ania. Titania. Helena is a Helena. Yeah, so we got moons all from them. All right. Now, so the reason I'm taking you down this circuitous path is because now you have this new planet, Uranus, farther away than the then farthest most planet, Saturn. And they said, well, let's track its orbit. Slow moving though it is, you can still check its orbit. They found out, it's not following Newton's laws of gravity. We know how this planet ought to be moving around the sun, and it's not. Newton's laws of gravity, the 1/r² law, two-body force, the sun and Uranus, it was not happening. There were slight deviations in it. And that worried people because no one had ever tested Newton's laws that far away from the sun. Maybe Newton's laws have a functional limit beyond which they no longer apply. Now, how quick are you to discard Newton's laws? I mean, they're working, and Newton was a smart guy. That's a last resort. You don't want that to be your first step. That's a fallback position. So they said maybe there's an object out there, remains to be discovered, whose gravity is influencing the trajectory of Uranus. Maybe. So sure enough, They checked the equations, inverted the equations, and said, where must a source of gravity be in order to alter the orbit of Uranus this way? Okay? Took high-powered mathematicians of the day. They said, it's got to be there. And so they looked, sure enough, discovered a new planet. That became Neptune, the planet Neptune. Okay, this is good to us now. We've resolved Newton's laws. You factor that Newton's laws are good out to Neptune, good beyond Uranus. They work for Uranus. All right. Now they keep looking at the trajectory of Neptune now the farthest most planet, and they say, it's not following Newton's laws. Do we throw Newton out? No, come on, Newton is good. Newton's good to us, right? So they said there must be another planet out there influencing it, and thus was born the search for Planet X. Planet X was the planet that was influencing the trajectory, the orbital trajectory of Neptune. And Planet X remained this mysterious object for decades, upon decades, upon decades. Okay? Let's back up, put a pin in that. Let's back up for a minute. 1801. People know there's this gap in the solar system between Mars and Jupiter. Mercury, Venus, Earth, Mars. Then there's like this huge gap, and then you get to Jupiter. People said, I wonder if there's a planet there. So they started looking. As telescopes got better and better, with every better telescope you acquire, there's more stuff you get to see in the universe, either farther away that's bright or nearby that's really dim. Each of those are thresholds that you move beyond. Sure enough, 1801, January 1st, a new planet is discovered orbiting between Mars and Jupiter. They name it. They got the tradition now, named Roman gods and goddesses, so this one they named Ceres. You ever heard of Planet Ceres? Planet Ceres? No, you probably never heard of it. Probably never heard of it. It was in all the textbooks. Front page story. Planet Ceres discovered. Ceres, C-E-R-E-S. That's the Roman goddess of harvest. And that's now the root word to the word cereal, by the way. Cereal. That's the way how that works. See, we get that. So everyone was excited. No, they kept looking. And then they found another planet. And another. And another. And another. This went on. For like 60 years, they found the first 4 in the first sort of 50 years, and then another sort of dozen in the few years. Remember, telescopes are getting better by the decade. And they kept naming them, and they said, wait, pause. How big are these planets? Well, they're kind of small. Where are these planets found? Well, they're all in the same zone, actually. What kind of orbits do they have? They all have kind of the same orbits in this zone. How big is the biggest of these? It's smaller than the smallest of any other planet we've seen. How much smaller? Way smaller. A few hundred miles across. 800 miles across. Maybe they're not planets. Maybe there's something else. Maybe we've discovered a new swath of real estate in the solar system, befitting its own category. It took 60 years, but people finally realized what had been discovered in 1801 was the first and brightest object in a new place called the asteroid belt. Now there are hundreds of thousands of asteroids. We're rising through that number. One of them has my name on it. I double-checked before I agreed to accept it that it's not headed towards Earth. So you're not going to blame that one on me. Remember that Simpsons episode where he... Well, yeah, we need the moon thingies. Do you remember there was Bart Simpson once discovered a comet and was headed towards Earth, and then the townspeople went to burn down the observatory that had discovered the comet, just to sort of... When there's low science literacy, that's the kind of thing that happens. So, where was I before I interrupted myself? The asteroid belt. Thank you. That was 1801. Meanwhile, people are still looking for Planet X. As the 19th century draws to a close, there's a wealthy astronomer named Percival Lowell, Lowell of the New England Lowells, you know, the Cabots and the Lowells, the moneyed family, multi-generational families of New England. He was a fanatic, smart, a little off, but was a fanatic about the universe. Got a mountain in Arizona, built an observatory there, called it the Lowell Observatory, yes, and had the best observing conditions around. Moisture is bad for observing the night sky, so you move into the desert, and Arizona is not famous for its rainstorms. So there you have it. He launches the search for the modern, quote, modern search for Planet X. They said, guys, give me your best location for where you think Planet X is. All right, so they did the same kind of inverted arithmetic that had enabled the discovery of Neptune. They've been doing that for a long time. No one could find it. He's got the best telescope now, the best observing conditions. He says, give me the spot on the sky. He looked, can't find it. Looks again, can't find it. Still fanatic about it. He ultimately dies. Someone else is hired to carry on this search, Clyde Tombaugh, 24-year-old amateur astronomer, farm boy from the Midwest, hired into the Lowell Observatory to pursue this survey. So instead of now doing targeted looks, I think it's there, no, nothing there. I think it's there, no, nope. He said, let me do a systematic scan of the sky. And the way to do this, you can't just take a picture and say that's Pluto. You have to take two pictures. Because between one picture and the next, all the stars will still be in the same spot, but Pluto, or whatever your solar system moving object, would have moved from one picture to the next. So it takes two epochs of imaging to make this work. So it does a systematic survey of the night sky. Bada bing, discovers Planet X. Discovers it, 1930. It's there, everybody's excited. They know how much mass it must have. It must be sort of as massive as Neptune to have influenced Neptune to the amount that they saw that it was. Everybody's excited. If you look in textbooks of the day, it lists Pluto, the 9th planet discovered by an American. American never discovered a planet before. There it is, okay. How big is it? As big as Neptune. It's gotta be, of course, it's the Planet X. Then they looked a little closer and they said, well, it's not actually quite that big. Maybe it's smaller. No, it's maybe half the size of Neptune. No, maybe it's the size of Earth. No, it's littler than that. Decade by decade, our best estimates for the size of Pluto got littler and littler and littler. And come the 1970s, it finally settled out, and we learned that Pluto is smaller than 7 moons in the solar system. Pluto is a fit maybe from New York to Colorado, that kind of size. Okay? It was not the Planet X that everybody had been looking for. It just wasn't. It was an imposter. It wasn't its own fault. It was our own sort of layered expectations upon it that made it the imposter. Don't blame Pluto. Pluto's just being Pluto, right? So devastating was this drop in size that in the late 1970s, there were 2 geologists. I think their mixture was a geologist, an astronomer, or a chemist, some combination of people who care, who noticed this trend line in the size of Pluto over time and decided to make a plot. And the title of this paper is The Impending Disappearance of Pluto. And there's a fitting function to this curve, and it says if it continues at this rate, Pluto will disappear by 1984. Completely. Crosses the x-axis, there it is, gone. So it's a tongue-in-cheek article, of course, but it was duly published in a peer-reviewed journal, but it got people worried. Like, what's going on with Pluto? What are we trying to, what is our understanding, really? Meanwhile, school children throughout the land are learning that there are 9 planets. And they're learning that the most important science to know about the solar system is to memorize the names of these 9 planets. Back then, there wasn't much else to talk about. Saturn had rings. Jupiter had a spot. They have some specks we call moons. It's kind of about it. So no one's complaining that all you're doing is memorizing these objects in sequence from the sun. Nobody's complaining. Well, what of that planet X? Is it still out there? It turns out it's not. Planet X turned out to be a phantom, which I'll get back to in a minute. I'll get back to that, because that's not really the subject. Pluto emerged from the search for Planet X, and it's Pluto that's the subject. I'll get back to it later, back to Planet X later. So, turns out in America, since Clyde Tombaugh is American, ask around the world, how much do you care about Pluto? Most places don't care. Americans care. Most places in the world don't really care, any more than they care about any other planet. In America, they care about Pluto more than any other planet, more than any other cosmic object. Why? I have my theories. Is it because it's the littlest and the cutest? No, you don't know how cute it is. You don't know anything about it. It's a speck on the sky. There are littler objects in the solar system than Pluto. We got asteroids. We've got 2 moons of Mercury, of Mars, that are so little, their gravity doesn't create a round shape for them. They actually have like a potato. They look like Idaho potatoes. I think that's kind of cute. I hold a potato and hold it up to the photo. It looks just like an Idaho potato. No one's falling in love with Phobos and Deimos of Mars. So my theory is, my hypothesis is, to save the word theory for things that actually are tested and demonstrated. My hypothesis is rooted in the fact that Walt Disney first sketched the dog that shares the name the same year that Pluto, the cosmic object, was discovered, 1930. 1930. So in the American hearts and minds, the cosmic object and the animal have the same tenure. The same tenure. Also, when do you first learn about planets in school? It's early elementary school, right? If you're a normal kid and you're in elementary school, you're also watching cartoons. And you haven't learned about Roman mythology yet, chances are. So when the teacher says, class, here are the planets in order from the sun, you hear Mercury, it's just a word. It doesn't mean anything to you. It doesn't mean winged messenger god from Rome. No, it's just syllables strung together to make the sound Mercury. Mercury, Venus, Earth, Mars, Jupiter, Saturn, you're glazing over Uranus, Neptune, Pluto. You pop up because you know about Pluto the dog. And therein, a genetic link between is created in the classroom that you carry with you to the end of your days. I'm certain that this is why. Because in 2000, when we opened the $230 million Rose Center for Earth and Space here in New York City, part of the American Museum of Natural History, and we looked at the trend lines of what was going on in the solar system, we noticed, hey, let's ignore the fact that Pluto's puny. Let's not even hold that against Pluto. Because you got to watch out if you invoke that kind of rule, because if you do the math, Jupiter is more bigger compared with Earth than Earth is compared with Pluto. So if we were like Jupiterians, or Jovians they're called, and we were asked how many planets are there in the solar system, we'd say 4. Jupiter, Saturn, Uranus, and Neptune, and everything else would just be debris. Earth is just debris if you are Jupiter. So I'm not going to hold size against Pluto. I got nothing. That's not my issue. My issue is, in the 1990s, when we were researching this new exhibit, $200 million worth of new planetarium hardware and astronomy museum exhibitry, we said, hey, wait a minute. The biggest telescopes in the world, remember, anytime you have the next biggest telescope, you're discovering dim stuff nearby or other dim stuff far away that's bright. New telescopes in Hawaii were discovering icy bodies in the outer solar system. Okay, well, how big are they? Well, they're little, like Pluto. What are they made of? They're mostly kind of ice by volume, like Pluto. What kind of orbit did they have? Well, they got weird orbits, like Pluto. Pluto's orbit crosses the orbit of Neptune. It's that elliptical that that's what it does. No other planet does that. Not only that, it's tipped out of the plane of the solar system by 17 degrees. The next closest tip is Mercury, that's 8. Everybody else is plus or minus a couple of degrees within the plane of the solar system. So Pluto's tipped more than anybody else. It's elongated more than anybody else. It's icy more than anybody else. We said to ourselves, maybe Pluto is not the 9th planet. Maybe Pluto is the first object discovered of a new swath of real estate in the solar system. I kind of heard this story kind of before. We've been down this road before. What was Ceres? It was like the next planet discovered until we realized that we actually discovered a new place. By the way, books of the day, as they were raking in the planets in the asteroid belt, I got a book that says there are now 13 planets in the solar system. 13 planets. 1830 is the year of that book. 13 planets. Was it 13 or 12? Something higher than any number you've seen today, because they were counting asteroids in this tally. So here we are with a similar kind of story trajectory. You discover Pluto, everybody's excited, you call it a planet, now you find family. You find family. So we're cutting metal, we're spending $200 million, we don't want to have an exhibit that's going to be found wrong or obsolete months later. So we said, what's the trend line? Trend line is, let us group Pluto with its icy brethren in the outer solar system. That's what we did. If you're going to start grouping objects by properties, let's group the gas giants, Jupiter, Saturn, Uranus, and Neptune. That's a group of 4 we have on display. Let's group the rocky objects, Mercury, Venus, Earth, and Mars. That's a group of 4 on display. That's what we did. We didn't count planets. We didn't redefine planets. We didn't kick Pluto out of the solar system, even though a year later, that's what the New York Times headline showed. January 22nd, 2001. Page 1 headline. Below the fold, nonetheless, page 1. Pluto not a planet? Only in New York. That's what sent my inbox. It was out of control. Started getting hate mail from 3rd graders. Pissed off colleagues. Angry school teachers who built whole lesson plans around this. And I got branded public enemy for having rethought how we would present the existence of Pluto in the solar system. I didn't even do it unilaterally. I have colleagues. We got together and said, what's the best data? What's the trend line here? And I have a mock-up of that page 1. It's right here. By the way, January 22nd, 2001, what happened 2 days before then? Bush got inaugurated. George W. just got inaugurated. They're still counting dimpled chads in Florida. You'd think page 1 would be filled with stories about the transition of power. And okay, there's some, so here, this is a mock-up of that newspaper. On the first day, Bush settles into a refitted Oval Office. Fine. 37 new cardinals selected by the Pope. Okay, get some cardinal action up there. That's good. I have a problem with that. Iraq rebuilt weapons factories. It's fun to see stories before you actually go in there and find out what weapons factories were. U.S. officials say, all right, it's fine, you keep going. You're going to come on down here and wait that bit. Here it is. Pluto's not a planet, only in New York. There it is. It begins here, but it continues and goes half of a whole other page as you get in. So that's when my life went to hell. That's all I'm telling you. Okay? The Pluto files, while I have strong opinions about how we should think about the solar system, I reserve those for the last chapter, called My Advice to You as a Student, Parent, Teacher, or just Curious Adult. The rest of the book is a celebration of everybody's reaction to this phenomenon. We were the first public institution to rethink Pluto. 6 years later, the International Astronomical Union, it's not a labor union, it's a society of it's a membership, professional society of astrophysicists. They got together, formed a planet definition committee, introduced criteria for what would be a planet and what was. By the way, planet hadn't been unambiguously defined since ancient Greece. That's why there was all this controversy. Had it been defined unambiguously, there would have been no controversy. We're normally much better about it than this. It was never an occasion to have to define it. They said, let's define it. If you put a check in each of these 3 boxes, you're a planet. You ready? First box, are you round? Pluto's round. Pluto lovers wanted the definition to stop there. Then you get Pluto. But then you also get Pluto's moon, Charon. And you also get Ceres, the only round asteroid. Then you get all the other moons in the solar system, Pluto, Earth's moon. Then the count would go from 9 planets up to like 18 or whatever, like whatever the number is, 20, mid-20s. I have a comic in here, got permissions to reproduce all these great comics. There's, at the time, there's like a few weeks when it might have been that anything round was a planet, because that was proposed by the Pluto lovers out there. And so there's a comic that shows a teacher in front of a class, and it's got the sun and all the 9 planets and all these other planets there, and the captions, "No planet left behind," in the classroom. So when the vote finally tallied, 2 more criteria were added. Second one, are you the principal object in orbit around the sun? Pluto is, but its moon Charon is not. Okay, so Pluto now has 2 checks in the boxes. Oh, by the way, do you know who Charon is? The ferryman to ferry your unfortunate soul across the river into Hades, because you got to be the Greek. So you're Greek, because you've got to be Greek if you're the moon. And Pluto and Hades was Greek and Roman and Greek. Okay, so somebody's got his mythology. Very good. So where was I? Something was here. What was there? Oh, no, so this is my check boxes. Thank you. So the first check, are you round? Are you the principal eye? Yes. Third one, have you cleared your orbit of orbital debris? Pluto hasn't, no. Because it's orbiting this new zone where thousands of other icy bodies have been discovered. Hasn't cleared its orbit. By the way, this zone was predicted to be there at mid-century by a solar system theorist named Gerard Kuiper. He reasoned that if you go beyond the orbit of the outermost large planet, Neptune, then if there's no other large planet out there to have gravitationally vacuumed up the leftovers of the solar system, it should still be there. And at that distance, it would all be made of ice. So sure enough, you check out there, it's all ice. It's all there, and it's all debris. Pluto does not dominate that zone. Too bad, Pluto. No check in that box. You are not a planet. You are, the new designation, you're a dwarf planet. Dwarf planet. This upsets so many people. And I'm thinking, well, maybe it's not a demotion. Maybe it's just a subclass of planet. You might drive a compact car. You're not saying to yourself, gee, I wish I was driving an actual car. You know, you're not saying that to yourself. It's just a kind of car, a compact car. So there were those who said it's not a demotion for Pluto, and others who took it personally and are still on a rampage about it. Or just do the internet. Of course, you can do that. You're a Google here, so you own the internet, right? So check it out. There's this sort of Pluto underground, all right, that continue to fight this vote. And so there you have it. Oh, there's an extra. Oh, so Ceres becomes a dwarf planet. It's round, orbits the sun, has not cleared its orbit. So Ceres gets elevated from an asteroid to a dwarf planet. Pluto gets sort of demoted from planet to dwarf planet. There are other round objects out there, they're dwarf planets as well, but there's another category, I think, just to make Pluto feel good. And it's, are you round beyond Neptune, which means you're mostly ice, then you're a Plutoid. A Plutoid. Some people didn't like that one. It sounded like some kind of skin disease or something. Do you have Plutoids? They get medicine for that, you know, kind of. So there you have it, the current sort of formal anatomy of the solar system. And I don't have a strong opinion about the definition of a planet. We never counted planets. What I care about is that if, however you define planet, I want you to admit to yourself that it's not the most interesting information you can convey about the solar system. If I say, I just discovered a planet around another star, you're going to ask me, is it big, is it small, is it rocky, is it gaseous, does it have rings, is it in the habitable zone, does it have moons? We got to play 20 questions just for you to get satisfied by the answer. That fact tells you that the word planet is just not that useful to understand the identity of these objects anymore. Wait, by the way, I'm not asking for much here. If there's a bookshelf, are there any bookshelves here at Google? Okay, just checking. because all your content is online, so there'd be no bookshelf. Oh, yeah, okay. So, you get a bookshelf. If I say, oh, could you go bring me the book from the shelf? Go bring me the encyclopedia that's on the shelf. Go bring me the dictionary that's on the shelf. Go bring me the pamphlet that's on the shelf. Go bring me the paperback that's on the shelf. All those words mean something different to you. I don't just say to you, go bring me the wood pulp that's on the shelf. You won't know what to bring. It's all wood pulp, all of it. It's not useful to you to have this conversation. So, in my pontificating, say for the last chapter, I just encourage people to explore the full breadth and depth of what we actually have learned about the solar system and create conversations based on that. And you'll come away not with the urge to have to memorize content, as school children are now doing, but the understanding of what the form and shape and contents of the solar system is what will emerge. And that's really what this is all about anyway, in like cosmic enlightenment of an audience. And so that's all I got to say. If you have, let me add one thing just about Pluto the dog, if I may. Got nothing to do with, and I got to tell you what happened to Planet X. These are my two ending points, and then we go to Q&A. Was that the, there you go. Did the camera get that? You got the sounds? Pluto, I work in I'm an astrophysicist who works at a natural history museum. So I hang out with people who study animals other than humans, as well as those who study humans. They're anthropologists there, in addition. And so I have a certain osmotic sensitivity to the animal kingdom that I wouldn't otherwise have. So when I learned that Pluto is Mickey's dog, but Mickey is not Pluto's mouse, that disturbed me deeply. Something is wrong in the mammalian order of things, because dogs can eat mice, all right? So I had to get to the bottom of this. So I asked, I got some Disney people, I called. I said, what gives here? So I learned, not that you asked, but I spent a lot of time digging this up. I gotta share it, all right? You're getting it whether you wanted it or not. It turns out in the Disney pantheon, among characters they created, not characters that they bought later, like Winnie the Pooh, I'm talking about pure Disney characters. No matter what creature you are, if you wear clothes, you can own other creatures who do not. It's that simple. Mickey's got the vest or whatever, he's getting the shoes and the gloves. Pluto's butt naked. There it is. Pluto walks on all fours and does not speak. He arfs, right? Meanwhile, Goofy wears clothes. Goofy is bipedal, okay? Goofy lives in a house, pays rent, not in a doghouse, okay? There you have it. I know you were burning to know this, all right? All right, let's knock out Planet X and we'll go to Q&A. Planet X. It took until the 1990s, believe it or not, for someone to realize, let's take another look at this baseline of observations that established that Neptune was misbehaving in its orbit, behaving badly not according to Newton's laws. And now we've tested Newton way out to the outer limits of the universe, so we're not giving up Newton on this one. But no one was finding Planet X in all the places it should have been. So he goes back to, this is, so in this effort, the guy who discovered this is Miles Standish, by the way, and he's got some Roman numeral after his name, so he's surely traceable to the Mayflower, where the first Miles Standishes to walk these shores arrived. But he's an astronomer, and so he looked at the data and says, wait a minute, the data from one of these telescopes is sort of a little more different from the rest of these telescopes, because you combine telescopes from multiple observatories over, 100 years, and he goes to the logbook of this other telescope and finds out, I forgot exactly what, it's like, oh, I will decide to clean the gearbox tonight, okay? The guy messed with the telescope clock drive. before he took measurements. You don't do that. You don't do that in the middle of your measurements. You keep everything the same as it ever was if you want a common baseline of what was going on. He said, let's just test this hypothesis. He removes the data from the fit that came from that one telescope and used the data from all the other telescopes in the bank. All Neptune's orbital parameters fit right into Newton's law. And Planet X evaporated overnight. So Planet X was, it was like Planet X was inside the gearbox. That's what that was. How else to say it? It was just a hardware artifact of one observatory in the data. So all gravity is accounted for in the solar system. Everywhere. Now, that's different from this Planet X that people have been talking about lately, who are worried that the world will come to an end in the year 2012. These are the end of world people. If you didn't know about this, then try Googling. Can I say that here? Googling 2012. Website upon website upon website of people who are sure the world will come to an end because a Planet X called Nibiru or Nimbru is coming and will knock Earth off with its axis. But it's all a fiction. It's a complete fiction. Gravity accounted for, beginning to end. There you have it. Just since I said it, the year 2012, there's the worry that on December 21st, the center of the galaxy, the sun and the moon, and the sun and the Earth will come into perfect alignment on December 21st, 2012. And if you check your orbital parameters, you find that that's true. We will come into exact alignment with the center of the galaxy and the sun. There's the claim that that extra gravity will knock us off our axis and end of the world will come. You can calculate how much gravity that is. And holding aside from the fact that it's not more gravity, it's just like, hold that aside. If you're worried about that, those same websites, what they don't tell you is that alignment, that exact alignment of the center of the galaxy where there's a black hole, the sun and Earth, that exact alignment December 21st, 2012, happens every December 21st of every year. They left that out. Anyhow, thank you for your time and attention. I think I spoke a little too long here. Any questions about Pluto? Yes.
I'll ask a question. Thanks for coming. Pleasure to have such a luminary in the office. I think I'll take this out because it's short. So my question isn't technical, but it's about sort of what you do as what seems like a science evangelist. And you're here, and I've seen you on the Colbert Report a lot. I know you're writing, and you're on TV. So what do you think the state of affairs is in science and kids in science and people reading books and America not falling behind all kinds of other countries, and what's on your mind when you're going about your work? Like, what do you think your responsibility is, and what do you think people like us, our responsibility is in a company like Google? Can you just sort of pontificate about that a little bit?
We have 3 more hours of tape, is that right? Can we?
Thanks.
I'll try to be efficient in my reply. First, I have very high hopes for the country. There are many signs of this. One of them is, of all the times you may have seen me on television, 85% of them came about not through any action of my own or some marketing group or some product that's being peddled. 85%. They are come about because the universe flinched and the producers want a soundbite, and my office is 10 blocks north of their studios. So I'm an easy date. So it doesn't get to my head that they keep coming. I'm an easy date. I try to give them a good soundbite that works, that's truthful, fun to listen to, and makes you want to think and do more. 85%. 15% come about because I've written a book, or I host a TV show on PBS. 15%. So where does the other 85% comes from? Somebody's deciding that their audience wants to learn about the universe. I'm not twisting arms. I'm not feeding them news stories. I'm at home. We're in my office, minding my own business, and the phone rings. I think that's a good sign, because if producers feel this way, that means if their understanding of their marketplace, they believe that the public feels that way. So that's one. Another one is, way back when I was a kid, you'd have to go months before you came across a science show on television that was not sort of about animals in the jungle or the undersea world. Those two were regulars. But for the rest of the science, you go months before you saw a show on the science. Now, anytime you sit down, every other time you sit down, you can land on a TV program that's on the universe, on black holes, on the Big Bang, on DNA, on climate. So it's there. It's available. There are producers, funders making these products. Third point. You say you're worried about kids. I'm not worried about kids. I'm worried about grown-ups, okay? These are the ones who vote. These are the ones who tell you the world is coming to an end in 2012. Kids don't say that. Grown-ups do. I'm worried about grown-ups who say, read my horoscope. Tell me whether I'll find money tomorrow. Grown-ups say this, not children, okay? Children do not read horoscopes, okay? Children are perfectly happy counting through the number 13. Children are not afraid to walk under ladders. They see a black cat cross their path, they say, oh, look, kitty, kitty, they want to pet it, and not run in the other direction. Children are not the problem here. Get me started. Plus, kids are born curious. They're always exploring. We spend the first year of their lives teaching them how to walk and talk, and the rest of their lives telling them to shut up and sit down. So there you have it. Plus, Obama put science right in his inauguration speech, so we want to hold him to that. And early signs in his administration and in Congress show that might actually come to pass. Plus, in America, a capitalist nation, where many people, if not most, don't want to die poor. Once you understand the role of innovations in science and technology as an engine of economic growth, then you are left with no other choice but to value and respect not only those who go into sciences, but you value and respect the science literacy of the nation when it comes time to voting monies in support of such projects. So that's my answer to your question. Yeah. Another question, sir.
Okay, I was one of the people who was kind of sad about Pluto not being a planet.
Are you still sad?
Well, I'm less sad now that you explained the thing about sweeping up the other bodies in the same orbit. That makes sense. But what I want to know is Pluto going to sweep them up?
Good question.
And maybe then it'll be a planet again?
Good question. Okay, in 87 trillion years, no, Pluto, the one way to ask the question is, let me back up. Earth plows through 200-300 tons of meteors a day. This is debris that is in the way as we move in our orbit. I do the calculation in the book. I forgot the exact numbers, but that sounds like a lot. By the way, this includes all the shooting stars you see at night. You add all those up. A couple of 100 tons a day as we orbit the sun, because we're moving 18 miles per second around this. That's fast. So we're doing a little sweeping up of our own. Ask, how much total mass is there that we could sweep up? And compare that to the mass of Earth itself. If you do that, it is a mere pittance of our current total mass. So you can declare that we dominate the mass of our zone. Pluto does not. If you look at all the mass that it could interact with, collide with, scatter, there's a process called scattering where you come really close and you redirect the path, like in a slingshot fashion. You can calculate how much mass is there for Pluto to interact with. It's factors greater than the mass of Pluto itself. So for all we know, if that all becomes one mass, Pluto won't be the mass it becomes. It could be join some other mass, even if it did happen that
But
way.
then it would sweep up Pluto. So then
Then it would sweep up Pluto,
then it
and that
might be
other object
Pluto.
would be the planet and not Pluto. Pluto would be a lost memory. Pluto would be some puddle of molten lava, where Pluto
But we
once
could
was.
call it Pluto, right?
You could call that section of your new planet the Pluto zone. It was like put a little monument to it. So that's a very sensitive thought that you had. That you shows deep love for Pluto. If one day it could dynamically become a planet again. So I deeply respect your love
Thank you.
for Pluto. Yes.
Hey there. Somewhat selfish question for Google. I heard kind of a...
I want Google Pluto.
Yes.
Okay, you got Google Earth. Okay,
Well, so
but you got to
along
go there first to get the surface map. All right. Right now, the best images we have from Hubble, it's a smudge. That's all you got.
So somewhat along those lines, when we did Google Space, it was kind of a collaboration, as I heard it, in the Pittsburgh office. We have some 20% time. One day a week we get to work on what we want. And there were some astronomers there who had all this data, and they just got to talking. And they're like, hey, let's put this together. You say you're at this nice New York location. We have a New York location. All this stuff that you guys use for the planetarium shows, those are great. I just totally love them. Those models are so awesome. The 3D models, the zoom outs up through Orion Nebula, all that stuff. Can we get a hold of those and put them in Google Earth and space?
Yes. Actually, we would have been up in your face with Google Space, Google the universe, before you even had that venture. The difference is, in our new facility, let's back up. You go into a planetarium, you're sitting down and there's the sky above you. In the old days, that was all it could do, show you the stars of the night sky. We wanted to take you to the next step. The next step was not just a closer up view of what's above you, we wanted to actually take you there. And to take you there required not an image of the object, but a three-dimensional understanding of its full structure. Okay. So we started building a library of the three-dimensionality of the universe. So it's not as you zoom up to the galaxy that you're getting closer to it, because you can get closer to a picture, but it's a magnifying glass. You're not going there. With our models, you can actually go up to the galaxy and enter the galaxy and take a look at it from the other side. That is the next step. It's the 3D step of the cosmos. And we got the data.
You want to share it?
Do we have that on tape? Do you want to share it? So we'd be happy to have conversations about that. And we use these 3D models. By the way, we have scientists as well as scientifically literate artists, computer literate artists, who can take the data and turn it into the beauty of these journeys that we share with our audiences. So it's exactly right. In the old days, you'd hire an artist to sort of paint the. We need an image of the surface of Mars. Paint one up for me. Now we have all the data, all the trajectories. We reproduced the asteroid collision that took out the dinosaurs. Old days, you might have just drawn what looks like an explosion. We calculate the trajectories, the debris. It's all ballistic trajectories. You can calculate all of that, and that's what we do. We've got it all. Almost not all of it. We got all the visualizations that we created for our shows. Of course, we've got that in our libraries. Happy to pursue that. Yeah. Other questions? What is my favorite space-oriented movie? I have two, and then I have my favorite sci-fi movie, which you didn't ask me about. Okay, should I start with favorite sci-fi? Definitely, without question, The Matrix. Without question. It only has one scientific gaffe in it, given the storyline that they're giving. There's one rather embarrassing gaffe, actually, but I'm going to let him slide, because the rest of the movie was so good. It was so good, Plus, I wanted to, do that. I want to dodge bullets myself. I just want to, and this has got to sort of dangle in the breeze as you, I want to be that. I want to, not Matrix 2 or 3, Matrix 1, yes, okay. So I would say, holding aside the classics like 2001, that sort of thing, I would say my favorite movies in the past 30 years, two. I would say Deep Impact. They got so much science right. That's the asteroid comes, takes out civilization. And it's not the Bruce Willis one. All right, Bruce Willis was in Armageddon, where he and oil driller buddies of his saved the world. And the asteroid in that movie was a comet that he went to explode because we're going to nuke it out of the sky. And it broke it into multiple pieces. Those pieces must have had homing beacons, because one hit the Eiffel Tower, one hit the Chrysler Building, one hit a dam, they had aim. Meanwhile, 70% of Earth's surface is water. All right, so Deep Impact understood this fact, and so its asteroid hit the ocean. But their producers understood that if you hit the ocean, you could still destroy the cities. Now you just do it with a tsunami, and that's cooler. That's kind of more fun. Okay. So, Deep Impact, and I'd say the Carl Sagan movie Contact. I thought that was brilliantly conceived and executed, and it was quite a study on what may be, we hope not, the human reaction, cultural reaction to a scientific discovery. I thought it was a fascinating probe of that. So those are my favorite space movies. The others I find to be just more pure entertainment, and I don't distract myself by them. The Star Wars and the Star Treks and the what's the other one? Yes, you do. Star Wars, Star Trek. Another one. No, not Battlestar. I actually had a cameo appearance in Stargate Atlantis, the TV show. Cameo. It was 6 minutes. That was it, and then I was gone. Quite on purpose. And here's what really upset me. I thought I did a really good job, and then I went home and saw it. It sucked. It sucked. So I'm not even going to tell you what episode it was, all right? Because I don't want you to know.
In the opening of the book, there's a really heartfelt letter of apology from a third grader. And since Pluto's demotion, I guess, have you gotten more kind of outpouring of, yeah, we're sorry, you're right?
Yeah, so in the Pluto files, some letters are transcribed. Others are scanned in, so you can see the crayon and the misspellings of the 7-year-old children who have sent me some of these emails. By the way, the only difference between the letters from adults and the letters from the children is that the adults spell their words better. But they otherwise have the same depth of emotion, and both are pissed off to no end. But you cite an interesting letter that I put in the front of the book from this might have been a second grader, third grader, who wrote me a letter after the vote was taken to demote Pluto back in 2006. The difference is a third grader today was born into the awareness that Pluto is reclassified. So they don't have this baggage, that the third graders back in 2000 did. So that's why the opening letter is a consoling letter, and I'll read it for you. It's just the openings in the front here. And it's before you even get to the table of contents, there's the letter. And you can barely read it. Dear Neil Tyson deGrasse, at first, remember all those kids that sent you bad letters? Well, I want to apologize that we said that we love Pluto, but that we didn't love you. Sorry about your mean letters. But he was apologizing for the letters. And then in the end, another letter from a third grader saying, people just have to get over this fact that Pluto is a planet. That's how science is. And so I figured, yeah, see, these are the kids. Kids get it. Kids are cool. Just the kids. The kids. So, if there are no other questions, we'd be happy to... Any other questions? About anything cosmic. I know it's supposed to be about Pluto, but yes. You got to go to a microphone, otherwise no one in the YouTube world will hear you. She's approaching the microphone now. Here she comes. Yes.
Okay, so I don't think the world is going to be destroyed in 2012 or whatever. But I thought they had said that there was going to be an alignment that hadn't been happening in a lot of time. Is that not true?
Yeah, it's a lie. That's called a lie.
Oh, okay.
It's an alignment that happens every year. Every year. And now be careful about people who make big deals about alignments. Because at any given instant in time, the configuration of planets is such that it won't repeat for 80,000 years or 100,000 years or a million years. And they'll say, rare planetary alignment coming up next Tuesday. Don't miss it. No one alive today or ever has ever seen it. And you think you're living in special times until you realize that a week later, there's another configuration of planets that no one has ever seen in recorded history. And so the week later, and a week later, and a week later, that if you have a million alignments that only happen once in a million years, then that's an alignment every year. So something can be rare, but not interesting. Something can be rare and not even special. And that's what happens when you see people touting rare alignments in the sky. Another one was, 5 years ago, there was Mars will come closer to Earth than it ever had in 60,000 years. Don't miss it. You say, wow, wow. And the New York Post had a huge, full Mars photo. And the story got out of hand. It said, you'll need sunglasses that night you'll be able to read by the light of Mars. And so here's what it was. You ready? Where? I'm in New York here now. Okay, you ready? Here, I'm standing right here, right? Which way is east? This way? Okay. I'm impressed that all of you pointed the same direction. That's good. I was asked that in a place. Everybody confidently pointed every which way. Okay, ready? That's east? Okay, ready? I go like this. No, I want to go west, so let's do this. Okay, ready? I've never in my life been this close to Japan. Okay? It's like, yes, Mars was closer than it had ever been in 60,000 years, but it was not anything. Anytime something says a rare thing happens in the cosmos and no one else has ever seen it, it's because they forgot all the other rare things that they could have told you about every previous day of the rest of the life you've led. Yes.
I have two questions. The first is about the planetary definitions, where has it been determined how round is round and how swept up is swept up?
Ooh, he's good. He's good. How round is round? It turns out that if you're small, as we are, the molecular forces overcome the tendency of gravity to turn you into a round shape. That's how we can keep our shape. That's why most of us are not spheres, okay? So, that's why. That's why a rock can be a rock. But the bigger your mass, the stronger is what we call your self-gravity. And what happens is the force operating on your physical structure ends up overcoming the molecular strength of your material body. And since gravity pulls equally in all directions towards a central point, the only shape that comes out of that force is a sphere. Earth itself is, for all intents and purposes, a sphere. You might say, well, we got Mount Everest, and we got valleys, and excuse me. Do you know the deepest point of Earth's crust?
Marianas Trench.
Marianas Trench. Thank you. That's a good crowd here. Marianas Trench. Do you know how far down that is? 6 miles down. 6 miles down. Do you know the highest point above sea level?
Everest.
Mount Everest. How high up is that? Why'd you give one in miles and the other in feet? Can we keep the same units here? About how high up is Mount Everest?
5.5 miles.
5 miles. So the lowest point on our crust to the highest point is like 11 miles. It's less than the length of Manhattan. To go from the deepest point in the deepest part of the deepest ocean to the highest point of the highest mountain range is 11 miles. Marathon runners they get to that after an hour and a half, after an hour on the road. And how wide is Earth? 8,000 miles across. Do you realize that 11 miles on 8,000? If you were a cosmic finger and came up to the Earth and rubbed your finger across it, you would not be able to distinguish mountain from valley, from dry from wet. Because the depth of the grooves in your fingerprint would be greater than the texture on the surface of this planet. If you shrunk Earth down to the size of a cue ball, it would be the smoothest cue ball ever manufactured. Ever. So we're all deluded because the school globe in your classroom, you'd run your fingers over, oh, there's the Himalayan mountains, and they're lying. They are lying. Let me tell you how bad they're lying. You think of our atmosphere as this of great extent. Did you know that the extent of our atmosphere is thinner than the layer of shellac on that school globe? So the geologist has been lying to you your whole life. That's what. No, why did I go there? What did you say? I was happily answering your question, and now I'm all off in
how round and how swept up. And I had one.
So the roundness. Yeah. So if you're big enough, you're round. If you're not big enough, you're not round. Like Phobos and Deimos on Mars, and Mars. So the hope is that this transition is sharp enough so that it doesn't confound our efforts to classify.
Okay.
But there's a worry that, in fact, it might be a fuzzier transition than we're anticipating, and that could be another fight down the line. How good are we at determining who's round and who isn't? By the way, we're not including the fact that if you rotate fast, you get a little fat at the poles and fat at the equator and short at the poles. Saturn is a fast rotator, rotates once every 9 hours or something. It's 10% shorter pole to pole than it is across. We'd still count that as round. It's round but affected by rotation. That's how we would say that. About clearing the zone, it turns out that's easy to define dynamically. There's a calculation you could do. Whether or not it absorbed it, you can declare whether its gravity is really batting other pieces around. And that actually has a nice divider between who's cleared their orbit and who hasn't.
Okay.
So, but it's excellent point.
And then the other question I wanted to ask is just in space.
Well, that was a two-part version of your first question.
Yes.
Fine.
The second question is, with all the space exploration going on or planned or so forth, what do you find most interesting and most worthwhile in terms of where we could put our resources and efforts and what's planned and all that?
I like life. I want to find life out there. It's a huge universe. We're made of very common ingredients. Life on Earth is hydrogen, oxygen, carbon. This stuff is everywhere in the cosmos. It's chemically fertile. You make molecules with carbon, So if you want to believe that life on Earth is the only life in the universe, in a way that's kind of inexcusably egocentric. There's no accounting for that attitude, unless you have some sort of philosophy that requires it of you, but it's not based in data or evidence. Okay? Unfortunately, so many philosophies people carry with them today have no foundation in the observation world. Anyway, it's unfortunate because people go to wars over philosophies. So I want to look for life. And life on Earth, if we use that as a starter kit, thrives in liquid water. So if you want to find life, let's look for liquid water out there. And so we know Mars has all this evidence of once having had liquid water. We think it's submerged and now in a permafrost. And maybe if these pressures are high enough, some of it might have been liquefied, creating aquifers. Recently we found methane emerging from one of the cliff faces of Mars. Methane. You can make it without biology, but biology kind of does it for free with sort of anaerobic microbes, the kind you find deep in the digestive tract of farm animals. Methane is an active ingredient in farm animal flatulence. So not that there are cows on Mars, that'd be an interesting find, wouldn't it? But that the microbes active in the anaerobic microbes, it's a whole variety of microbes that thrive where there's no oxygen. So we're intrigued. I want to go digging in those soils. One of the moons of Jupiter, Europa, is kept warm. It's way outside of the green zone, that zone where this Goldilocks zone, where the temperature is just right. Because if you're too close to the sun and you have liquid water, you evaporate. Too far away, you freeze. So there's a zone where it's just right, where it's liquid. Europa is well outside of this green zone, this old Goldilocks zone, yet there's an ocean of liquid water, been liquid for a billion years. Turns out the gravitational stress of Jupiter on that moon, combined with stresses triggered by other moons, is pumping energy into that orb. And when you do so, where does the energy go? It melts the ice. I want to go to Europa and go ice fishing on Europa, cut a hole and see if anything swims up to the camera lens. And it's called the Jupiter Icy Moons Orbiter, JIMO, which is currently unfunded or it's on hold for other projects that are coming. That would sort of map the surface to choose. Orbiters will always map the surface for you for the lander that will come later. And then you got to be clever about how do you sort of go through the ice. Do you cut? Well, what do you do? It's probably 1 kilometer thick. Do you melt it? Then you have to sterilize the spacecraft you send there. You don't want somebody sneezing on it while it's in the lab here, and then you go there, hey, we just found, the rhinovirus, They have influenza on, Nope, it came out of your nose, sir. You didn't wipe your nose before you packed the spacecraft. So you want to make sure that you're not discovering your own self. Plus, one way to melt the ice is to have sort of a radioactive heat source. But then you don't want to, get radioactify your, so it's a hard problem. How do you explore a planet, a surface that might have life that you don't want contaminated? So those are my top ones right now. I like the Super Collider going on in Switzerland right now, probing the limits of the energy of the universe, give us insight into what was going on in the Big Bang. Search for dark matter, dark energy, 2 areas of profound ignorance in modern astrophysics. 85% of all the gravity in the universe comes from something we have no idea what it is. 94% of everything that is the universe. That's what we call dark energy. We measure it, it's there, we don't know what's causing that either. So people say, are you worried? Are you upset? No, I'm actually quite titillated. If you're a research scientist, you're drawn to areas of the unknown. You don't fear them, you embrace them. You're seduced by them. So thank you all for your time and energy. All right.